You probably use Google like every single day. But what if the very foundation of this digital empire is actually already
I
crumbling?
mean, it sounds almost unthinkable, right?
Yeah.
We just tend to view these tech monopolies as these permanent fixtures of our reality.
Yeah, they feel like public utilities at this point.
Exactly. But historically, when the underlying architecture, a technological era, becomes fundamentally unstable, the whole edifice can just collapse. And it usually happens surprisingly fast.
Which perfectly sets up the core mission of today's deep dive. We are examining George Gilder's incredibly provocative book, Life After Google, The Fall of Big Data and the Rise of the Blockchain Economy.
It is a really fascinating read.
It really is. And we're going to explore his central thesis, which is that Google's system of the world, this whole structure built on big data, centralized cloud computing, and, free services, is structurally insecure.
Yeah, structurally, fundamentally insecure.
Right. And because of that deep insecurity, the author argues it is destined to be replaced by a decentralized, blockchain-based economy, something he calls the cryptocosm.
Which, if you look back at the history of computing, it provides some great context here. We went from giant, centralized mainframes to decentralized personal computers.
Right. Yeah, the PC revolution.
Exactly. Yeah. And then back to centralized cloud servers again. These massive paradigm shifts, they always occur when the current system hits a wall, like a physical or architectural limitation that it simply cannot innovate its way around.
Okay, let's unpack this. We have to start by looking at the most appealing part of Google's empire for, well, you and me. The fact that almost everything they offer is seemingly free.
Right.
You get these world-class maps that navigate you through traffic, you get endless email storage, instantaneous search results, and you never once pull out your credit card.
Not once.
But according to the author, that exact feature is its fatal flaw.
Yeah, that is really the anchor of his critique regarding what economists call the zero marginal cost society.
The zero marginal cost society.
Right. The author argues that when a product is free, you are not actually the customer. Apple's Tim Cook has famously pointed this out as well. If the 7-Up is free, you are the product.
Your attention, basically.
Your attention, your behavioral data, your time. Those are the actual currencies changing hands behind the curtain. And this creates a cascading architectural problem.
Because they aren't charging us money.
Exactly. Because these services are free, the tech companies avoid the traditional liabilities and direct customer relationships that normally force a business to build foundational security.
So it's like an all-you-can-eat buffet where you don't pay a dime, but the restaurant keeps a copy of your house keys, tracks your every movement, and takes meticulous notes on how you chew your food.
That is a very vivid image.
Well, eventually someone is going to break into that key drawer, right? And when they do, the restaurant just sort of shrugs and tells you to go change your locks.
That is a perfect way to visualize it, because the security isn't tied to a paying customer's demands. It just becomes an afterthought.
It's just a Band-Aid.
Yeah, it gets bolted on later with software patches, endless password requirements, and those Capity CHA puzzles.
Oh, I hate those, where you have to click all the traffic lights just to prove you aren't a robot.
Right, exactly. The security is not baked into the foundation. Furthermore, the entire business model relies on aggregating massive amounts of your personal data to sell targeted advertising.
Which means they have to store it all somewhere.
Right. It has to be centralized in what the industry calls walled gardens. They hoard petabytes of personal information on massive centralized servers, turning them into just giant, irresistible honeypots for hackers.
What's interesting is Gilder uses a very specific and frankly quite provocative economic lens to describe the philosophy driving this.
He does, yeah.
What's fascinating here is how he characterizes the prevailing mindset in Silicon Valley as a form of neo-Marxism. Now, we need to be clear for the listener, we are looking at this strictly to understand his economic thesis. We aren't taking a political side here.
Absolutely. We're just neutrally reporting his framework.
Right. And his argument is that traditional Marxism believed the Industrial Revolution had permanently solved the problem of production. Therefore, the only problem left for society was just the redistribution of that abundance.
And he draws a direct parallel from that to today's tech titans. Because they have achieved this zero marginal cost digital abundance, where copying a file or running a search costs fractions of a penny, they behave as if the fundamental human challenges of economic production and scarcity are essentially over.
Right. Like the hard part is done.
Exactly. In their minds, their only remaining role is to act as the central planners of the network.
Yeah.
Just redistributing this digital wealth for free while harvesting the data.
But if that free model creates this massive security nightmare with our data, why do they cling to it so tightly?
Because they desperately need it.
Right, they need that constant flow of your data to feed their algorithms, which brings us to the philosophical core of their entire system, big data and artificial
Yeah,
intelligence.
and to understand why they need all this data, we have to look at a concept called Markov chains.
Markov chains.
Yeah, it's a statistical tool introduced over a century ago by a Russian mathematician named Andrei Markov.
Okay.
Essentially, a Markov chain predicts the future based entirely on a present state, without needing to understand the underlying meaning, context, or history of the data.
So it just treats events as a sequence of mathematical probabilities.
Exactly.
So it's kind of like predicting tomorrow's weather based entirely on a massive spreadsheet of what the weather was yesterday, without actually understanding meteorology or atmospheric pressure or, how clouds even form.
That is exactly how it functions. It is a brilliant mathematical shortcut. I mean, Google's foundational search algorithm, PageRank, operates as an enormous Markov chain.
Oh, really?
Yeah. It ranks web pages by mapping the random walks of millions of internet surfers, calculating the mathematical probabilities of where a user might click next.
But it doesn't know what it's looking at.
Exactly. It doesn't actually comprehend what the web page says, it just follows the statistical breadcrumbs.
Uh-huh.
We see the exact same tool used by Renaissance Technologies, which is this incredibly secretive hedge fund mentioned in the text.
Right, the ones making billions of dollars.
Right, by using supercomputers to find tiny, high-velocity mathematical correlations in global financial data. They aren't analyzing a company's leadership or their new products or market fundamentals. They are literally just riding the Markov chains to predict the next price tick.
And the author argues this complete reliance on big data has led Silicon Valley to a very specific and honestly somewhat dark view of humanity.
It really has.
Because these algorithms process data so effectively, the tech elite have started treating the human mind as just a suboptimal, random evolutionary algorithm.
Right, like we're just bad computers.
Exactly. They believe it is only a matter of time before our biological wetware is completely surpassed by silicon machines. They call this the singularity, or Life 3.0, predicting a future where machines take over the commanding heights of intelligence.
Which is a huge claim.
It is. And wait, let me push back on this for a second. Isn't AI genuinely getting smart? I mean, we look at programs like Google's AlphaGo, which famously beat the human world champion in Go.
Right, an incredibly complex game.
A game of pure strategy. Doesn't that prove these machines are actually outsmarting us in real time?
It seems like it, but the author provides a very strong rebuttal to that exact argument. He leans heavily on the theories of mathematicians Kurt Gödel and Alan Turing.
Okay, lay that out for us.
So the core counterargument is that speed of processing is not the same thing as consciousness or actual intelligence. When AlphaGo plays millions of games against itself in a matter of days, that is incredibly fast iteration. But
This is within a box.
exactly, it is taking place within a closed, deterministic system with fixed, unchanging rules.
So it's a closed loop. It can master the loop, but it can't invent a new game.
Spot on. Gödel's incompleteness theorem mathematically proved that all logical systems are fundamentally incomplete. They cannot prove their own foundational axioms from within.
They need something outside the system.
Yes, and Turing showed that a computing machine requires what he called an oracle, a human mind outside the machine, to give it instructions, write its code, and actually judge its outputs. A machine processing a billion parameters is just doing incredibly fast math.
But it doesn't actually know anything.
Exactly. It has no actual knowledge.
The text also brings in Claude Shannon, the father of information theory, which I found totally fascinating.
Oh, Shannon is brilliant here. He argued that true information requires surprise, or what he called entropy.
Surprise.
Yeah. If a system is purely deterministic, just following rules and crunching probabilities, it cannot be surprised. It cannot generate a truly novel thought.
Because it's just predicting the next most likely thing.
Right. It lacks consciousness, which is the actual source of creativity and new knowledge.
Meaning, if you rely entirely on Markov chains and big data, you are just endlessly recycling the past. You can never truly create something fundamentally new because real innovation requires human intuition and the ability to step completely outside the deterministic rules.
Gilder views this as the ultimate fallacy of the Google era. They mistake the map for the territory. They assume that because a computer can simulate intelligence through sheer processing speed, it actually possesses intelligence.
But while this software philosophy might be philosophically flawed, the sources point out it is also hitting a brutal physical limitation.
Yeah, the physical reality is catching up.
It really is time to transition from the abstract algorithms of AI to the massive heat-generating physical reality of the cloud. We toss that word around a lot.
We do.
We say our photos and emails are in the cloud as if they're just floating in the ether, but the cloud is intensely physical.
It is an incredibly heavy, resource-intensive industry.
The cloud is actually massive, power-hungry data centers. The text details a specific Google facility in the Dalles, Oregon. And they didn't build it there for the scenic views.
No, definitely not.
They built it right next to the Dalles Dam on the Columbia River, a massive hydroelectric power station. They need that gigawatt of power, mostly just to run the giant air conditioners, so their tens of thousands of servers don't literally melt down from the heat they generate processing all that free data.
And this brings us to the physical wall. For decades, the tech industry has just coasted on Moore's law, right?
The idea that computing power doubles and gets cheaper every couple of years as we shrink transistors.
Exactly. But there is a corollary called Bell's law, stating that every decade, a 100-fold drop in the price of processing power creates a totally new computer architecture.
Okay.
And Gilder points out that we are now hitting quantum uncertainty limits.
Which sounds like total sci-fi jargon, but what does that actually mean for the microchips?
Well, to put that in perspective, the transistors on a modern microchip are now just a few atoms wide.
Wow, just a few atoms.
Yeah. And at that microscopic level, physics gets weird. Electrons start tunneling, basically teleporting through the microscopic barriers that are supposed to contain them.
So the chip just leaks?
Pretty much. The chip can't accurately hold data anymore without generating uncontrollable heat. The physical laws of the universe are dictating that you can't just keep cramming more silicon into a centralized warehouse and turning up the clock speed. The energy constraints are absolute.
And trying to fix those absolute physical limitations with more software actually leads to massive real-world engineering failures. Here's where it gets really interesting.
This is a great example.
The sources provide a perfect story about this, featuring a young entrepreneur named Austin Russell and his company Luminar. They build LiDAR systems, the laser radar vision systems used for self-driving cars.
Right, which is a critical technology for AI trying to navigate this messy physical world.
Now, the standard Silicon Valley approach, used by Google's Waymo and others, was to take existing, off-the-shelf spinning lasers, those spinning paint can-looking things, on the roof of early self-driving cars.
We've all seen those.
Right. And they try to fix the low-quality, fuzzy data those lasers gathered by writing increasingly complex AI software to just guess what the car was seeing.
Right, trying to fix hardware with software.
Exactly. In engineering, they call that a kludge. Just patch over a hardware limitation with a messy software workaround.
Because software is what Silicon Valley knows how to do.
But Austin Russell recognized that software cannot magically create good data from a blind sensor. You can't code your way out of physics. If the laser data is bad, the AI is just making highly educated, dangerous guesses.
Which you do not want in a car moving 60 miles an hour.
Exactly. So instead of a software kludge, he built an entirely new integrated hardware system from the ground up. He changed the physical wavelength of the laser from 905 nanometers, which can literally blind human eyes at high power. Yeah, he changed it to 1550 nanometers, which is eye-safe. And because it's eye-safe, his hardware can operate at 60 times the power. He even used a completely different material, indium gallium arsenide, instead of silicon for his microchips.
And the result is that his LiDAR can see hundreds of meters down the road perfectly in the dark.
Yeah.
It creates such high-fidelity 3D data that the car's computer no longer has to guess using complex AI.
It is a total validation of the author's point. Software can't eat everything. At the end of the day, hardware, atoms, and the actual physical laws of the universe still matter.
They absolutely matter. And that physical reality provides the perfect pivot point for the book. If these centralized data centers are hitting absolute thermal limits, and if AI is just incredibly fast math requiring massive power, and if the centralized free model is fundamentally insecure.
Then what is the alternative architecture?
Exactly. This is where Gilder introduces his proposed solution, the cryptocosm.
The cryptocosm. I mean, it sounds like a realm from a fantasy novel, but it is a very real architecture being built right now.
It is. The author outlines the 10 laws of the cryptocosm, which serve as the foundational principles for this new era. And it is essentially a total inversion of the Google model.
Okay, so what's law number one?
Law number one is security first. Security must be the foundational architecture of the network, not a keep PCHA puzzle applied later.
That makes sense.
Another crucial law is that centralization is not safe. Centralized data hoards will always be honeypots for hackers. True safety requires distributing the data peer-to-peer.
Right.
And perhaps most importantly, nothing is free. Money is an essential signaling mechanism that respects the value of the creator, the customer, and the scarcity of time.
And this naturally leads us into the world of blockchain and cryptocurrencies. The text dives into the origin of Bitcoin and its mysterious creator, Satoshi Nakamoto.
Oh, the origins of Bitcoin read like a thriller.
They really do.
Satoshi Nakamoto released the Bitcoin white paper in 2008, launched the network, and then just completely vanished, leaving behind the self-sustaining, decentralized protocol.
And the drama that followed is wild. The sources even detail the bizarre story of Craig Wright, an Australian computer scientist who aggressively and publicly claimed to be Satoshi Nakamoto.
Right, he tried to claim copyright over the white paper?
But he continually failed to provide the one thing that actually matters in the cryptocosm, which is cryptographic proof. He couldn't move any of the original Bitcoin, leading to his widespread rejection by the crypto community.
Which perfectly illustrates the point. In a system built on cryptographic truth, you just can't fake your identity.
Alongside Satoshi, the text highlights Vitalik Buterin, a young prodigy who realized the blockchain could be used for much more than just digital money. He created Ethereum.
Which is a decentralized platform designed to execute smart contracts.
Right, and to understand a smart contract, you can just imagine a digital vending machine.
Okay, a vending machine.
Yeah. There is no human employee standing inside the machine making sure you get your soda. You put in the coin, you press the button, and the physics of the machine automatically dispense the drink. Ethereum scales that concept globally. You can have entire corporations, financial agreements, and complex transactions run automatically by code across a distributed network, executing exactly as written with no central gatekeeper, CEO, or middleman to stop it or take a cut.
Now, I get the appeal of decentralization. I get wanting to own my own data and cut out the middlemen. But I have to ask a vital question on behalf of you, the listener.
Okay, lay it on me.
How does mining Bitcoin actually create any real value? We've talked about data centers hitting thermal limits. Isn't having massive warehouses of computers churning through arbitrary cryptographic math puzzles just a digital version of digging a hole in the dirt and then filling it back up?
Right.
It seems like a colossal waste of electricity.
That is the most common critique. But Gilder provides a very specific physics-based defense of this process. It all comes down to time and thermodynamics.
Thermodynamics.
Yeah. Think about the digital world today. Anything can be copied infinitely for free. An MP3, a digital photo, a text document. So how do you create something digital that is fundamentally scarce and therefore actually valuable?
Yeah, to prove that real work was done to create it.
Exactly that. Bitcoin creates a standard of value by linking the irreversible passage of time with the physical expenditure of computer processing cycles. The math puzzles the computers are solving, the hashing algorithms are intentionally difficult and incredibly energy intensive.
So they require actual power.
Yes, and when a computer solves the puzzle and adds a block of transactions to the chain, it provides an unforgeable proof of work.
It proves that real-world electricity and real-world time were irreversibly sacrificed.
Exactly, and that sacrifice establishes a secure, immutable ground state. Because the math requires so much physical electricity to solve, a hacker trying to rewrite the ledger or fake a transaction would have to outcompute the entire rest of the global network combined.
Which is physically and financially impossible.
Right. It creates a digital ledger that cannot be altered. And it does this entirely without a central bank, a government, or a tech giant acting as a trusted third party. The value isn't in the math puzzle itself. The value is in the creation of a completely unhackable, decentralized system of trust.
And the author argues this physics-based security is the only way to build a functional architecture for the future internet.
So let's look at the full picture of what we've covered today in this deep dive. We started by examining the hidden systemic costs of the free data economy, where your privacy is basically traded for convenience.
Right.
We moved through the philosophical limitations of AI algorithms that mistake incredibly fast math for actual consciousness. We looked at the physical wall massive data centers are hitting as transistors shrink to the quantum level.
And we've arrived at a vision of the cryptocosm.
A decentralized internet architecture where you actually own your data, where security is the foundation rather than an afterthought, and where value is tied to cryptographic proof rather than advertising metrics.
It represents a complete paradigm shift from top-down, centralized control to bottom-up, peer-to-peer empowerment.
So what does this all mean for you? It means that your personal data, your digital identity, and your attention are incredibly valuable. They are far too valuable to be quietly traded away to centralized tech giants just in exchange for a free email inbox or slightly faster search results.
Absolutely.
The architecture of the internet is shifting beneath our feet, and understanding that shift is the first step to reclaiming your digital sovereignty.
This raises an important question, though, a deeply provocative one to leave you with. If the future of the internet truly relies on the cryptocosm, a world where there is no central authority, and your digital identity, your data, and your wealth are secured entirely by your own private cryptographic keys, what happens to society when we are solely 100% responsible for our own security?
Yeah, that's heavy.
In a completely decentralized world, with no centralized forgot password button, and no customer service line to call when you make a mistake and lose your keys, are we truly ready for both the absolute freedom and the absolute unforgiving responsibility of the cryptocosm?
That is a very wild thought to sit with. Thank you so much for joining us on this deep dive. Keep questioning the architecture of the digital world around you, because as we've seen today, the foundation of that digital empire might be crumbling right under our feet. Catch you next time.